of the things that we've changed in this one are the clear coolant lines that you can see here. We were having troubles with cavitation of the water pump, which is this little Bosch water pump right here is for the cooling system, because the small channels in the motor and controller that carry the water would hold air. So we've added the clear line so we could see when we've got all the air out of it. We also had to add a second radiator, the small one down here. This one wasn't quite, this is for a 250cc motocross motorcycle, and it wasn't quite enough cooling on hot days. So we added this other small radiator and are blowing the air out the bottom of the car. What we do is we take in air at the high pressure zone between the interposition of the change from the hood to the windshield, where you create a high pressure zone. I don't know if you've noticed on NASCARs, their hood scoops face backwards. When I was a little kid, I asked Dad, why are they facing backwards? Wouldn't they catch more air if they're facing forward? I don't remember if he had an answer for me at the time, but I'm sure I didn't understand it. You actually get higher pressure at this change in shape of the vehicle than you do as if you're aiming forward, so you can pull more air in. We pull all our air in here. We don't need a scoop. It's just open. We have a small scoop on the bottom underneath of the hood, which creates a low pressure zone. So we take something from a high pressure, move it to a low pressure, we reduce drag, and we completely eliminate the drag from the front intake, the air intake that you normally have on a vehicle. Now this leaves us with a few interesting things where we have to vent like the AC condenser out the bottom of the car, and we have to vent cooling air for the heating system, or for the radiator out the bottom of the car as well. We were just venting it into the car, and it worked pretty good when the AC was on, because that would pull more air out and blow it out the bottom of the car. So what we did is we added this auxiliary radiator, which is a heater core from a 1984 Fiero, and we're using the condenser exhaust hole right now to experiment with to see how much more cooling we need. And we're just about right now. It gets a little warm, like yesterday we were out driving at 95 degrees. The car doesn't see the heat index, but it only sees 95 degrees. Driving it at highway speeds, and it was getting warm. But you can see here, this is an MES DEA 40 kilowatt liquid cooled AC motor. The controller for it is a TIM 600, sits right here on top. These are the high voltage lines from the battery pack, the two orange ones you see here, and this one covered in aluminum tape, actually for noise reduction, are the lines, the control lines and power lines that come out of the inverter and go to the motor. You can think of the inverter as like a volume knob on your stereo system. It takes, as you press on the accelerator pedal, it takes the signal from the accelerator pedal and it will turn up or down based on what you do in the accelerator pedal, the voltage being applied, voltage and current applied to the motor. Sitting next to it, we have a DC to DC converter. This takes the high voltage DC from the battery pack at 340 volts and converts it down to 12 volts, so we can run the 12 volt systems, the radio, the headlights, the side marker lights, blinkers, dash lights. The transmission is from a Geo Metro. It was originally a 5-speed manual. It is now a 2-speed, and we simply have the shifter on top. We had our local machinist make a little adapter for us. Normally it shifts on the bottom. Right now we're in 4th, neutral, 3rd. So that would be our low and our high. After our experimenting with this drivetrain, we found that 3rd gear in this one, which is now our low, is our fastest speed from 0 to 60. And 4th gear, which is high, is the most efficient speed at highway speeds. It was actually 2% more efficient to run at that RPM than it was the RPM in 5th gear. And that's based on the characteristics of the motor and the final drive of the transmission. How fast is the motor actually spinning? Most of them have a sweet spot. Our electric motor is 95% efficient for about 95% of its RPM range. When you're just starting out extremely low and extremely high RPMs, it drops off to about 70%. But there's a sweet spot right in the middle of that where it's about 97% efficient. And then our charge port is right here. High voltage charging, and it's connect first, break last for the ground. And then this side is the sensor wires, the computer wires that come from the charger to the car that monitor the charge and temperature of the batteries and tell the charger what's going on so it knows when to shut off.